students. Welcome to the English class. I am Oluwabumi Fakoya. I hope you are enjoying your holiday. I shall be taking you adjectives. But before we go into today's topic, let's quickly have a review of the work done last class. I gave you some rules on Concord at the last class, and I also gave you an assignment. I told you to construct 2 sentences on each rule discussed in the last class. I hope you have been able to construct error-free sentences. Well, let's just take these 2 examples to have a recap of the work done. I told you that plural nouns expressing one idea will take a singular verb. Plural nouns expressing one idea will take a singular verb. Take, for example, rice and beans is my best food. Rice and beans is my best food. Also, I also told you that there are some nouns. There are some words like nothing, everyone, anyone, that anytime we have them in a sentence, we must use a singular verb with those words. Now, take for example, anyone is permitted to come. Anyone is permitted to come. I hope you've been able to construct more sentences on the other rules. Now, let's go into today's topic, which is adjectives. Now, I'm sure you are familiar with this topic. And of course, I know that you can say 1 or 2 things about this topic. However, at the end of today's lesson, you should be able to explain adjective. You should be able to list and explain types of adjectives. And of course, you should be able to mention examples on each type of adjective. What is adjective? I believe you should be able to tell me where you are seated what an adjective is. An adjective describes or qualifies a noun or a pronoun in a sentence. An adjective describes or qualifies a noun or a pronoun in a sentence. And of course, I believe that we can eulogize God wherever we are, and can say 1 or 2 things. You can say 1 or 2 things about God. Say God is wonderful, God is awesome, is beautiful, is supreme. We can extend that even to man too. We say man too is handsome or beautiful. We say is wonderful. But note that God is above all. He is supreme. He is the supreme God. Now back to our lesson. We want to look at types of adjectives. Remember, an adjective describes or qualifies a noun or a pronoun in a sentence. What are the types of adjectives that we have? Can you list some? Because I'm sure you are familiar with this topic. Okay, let me give you some. The first one we want to look at is adjectives of quantity. Adjectives of quantity. What do we mean by adjectives of quantity? Well, these adjectives tell us the quantity of the nouns they describe. They tell us the quantity of the nouns they describe. Take, for example, some money was found under the chair. If you look at this sentence, you will look at some. It's giving us the quantity of money. And that's why I have underlined some, because that's the adjective in this sentence. So let's take another example. April is the 4th month of the year. Now, if you look at this sentence, Can you identify the adjective in this sentence? Okay, fourth is the adjective in that sentence. Can you also construct a sentence at home or wherever you are on adjective of quantity? And you can also indicate the adjective in that sentence by underlining the adjective that you have used in that sentence. But let's take one more example. Many houses were affected by the storm. Can you try and identify the adjective in this sentence? Okay. I'm sure you have underlined many in your notes, because many is telling us the number of houses, trying to qualify houses in that sentence. And of course, let's run through the examples again. Some is qualifying money, which is the noun in that sentence. April is the 4th month of the year. What's the 4th month? April. So the third sentence, many, is qualifying houses, telling us the number of houses affected by the storm. So many has been underlined as the adjective in that sentence. I believe you should be able to construct 5 more sentences identifying the adjective in those sentences. So that takes us to another type of adjective. This time we're going to look at adjectives of quality. Adjectives of quality. Now, these adjectives of quality, they tell us the qualities possessed by the nouns they qualify. They tell us the qualities possessed by the nouns they qualify. Take, for example, the beautiful flowers have a nice smell. Now, remember, we are talking about adjective of quality. Now, if you look at this sentence, you will discover that nice is an adjective there, and we also have beautiful as an adjective in this sentence. These two words are qualifying flowers, which is a noun in this sentence. Beautiful, the beautiful flowers have a nice smell. I'm sure you too, you are thinking about it. Maybe you have come across a particular flower that has a nice smell before. You know how such beautiful flowers smell. So say beautiful flowers have a nice smell. Now, can you construct a sentence at home using adjectives of quality? Or you can decide to use one adjective of quality in that sentence. Well, let me give you another one. Watermelon is sweet, but grape is sour. I'm sure you know how watermelon tastes when you take it. It's sweet, but grape is sour. Can you identify the adjectives of quality in this sentence? Okay? You say sweet, and you say sour. Sweet is qualifying watermelon, telling us how watermelon is tasting. And of course, grape is sour, telling us the taste of a grape. And I'm sure you can identify the two. You must have tasted watermelon and grape before. So we say watermelon is sweet, but grape is sour. So by implication, Sweet is qualifying watermelon. Sour is qualifying grape. We should also take another example, which is, I bought a brown pair of shoes. I bought a brown pair of shoes. We have brown here, qualifying the type of shoes that I've bought, which is a pair of shoes. So, I believe you should be able to construct more sentences using adjectives of quality. Let's take another type of adjective. Now we want to look at demonstrative adjectives. Demonstrative adjectives. Now, demonstrative adjectives point out the nouns or pronouns you are referring to. Demonstrative adjectives point out the nouns or pronouns you are referring to. We only have 4 in this category. We have this, we have that, we have this, and we have those. Now for this, which is CHIS, this is used to refer to a singular noun close to you. Singular noun close to you. Take for example, this bicycle is mine. This bicycle is mine. We have this there as a demonstrative adjective. This. And let me quickly tell you this. We have this as singular form, and we have this as a plural form. That is, this is the plural form of this. So, and we have that too. We have those as a plural form of that. So, let's look at that. For that, that is used to refer to a singular noun far from you. It's something that is far away from you. You can say, that mango is ripe. That mango is ripe. That is a demonstrative adjective in this sentence. So, as well, let's look at this, which is a plural form of the THIS, this. For this, we use it to refer to a plural noun close to us. Remember, I told you that this is a plural of this plural noun close to us. The plural noun close to us. Take, for example, these 2 cakes were bought. This is a demonstrative adjective in this sentence. So, the last one, which is those. Those is used to refer to a plural noun far from you. Plural noun far from you. You know, singular noun close to you. Singular noun far from you. Now, plural noun close to you. Now, those, plural noun far from you. Take, for example, those oranges are ripe. I believe that you should be able to identify the demonstrative adjective in this sentence, which is those. So, by now, you should be able to identify demonstrative adjectives in the sentences that you have constructed by underlining those adjectives out. So, we now take another type of adjective. Another type of adjective that we want to consider now is possessive adjectives. From the word possession, you should be able to know what possessive adjective is. These adjectives are used to show possession or ownership, that something belongs to somebody. So we say these adjectives are used to show possession or ownership of the noun they qualify. Remember, these adjectives are used to show possession or ownership of the noun they qualify. Take, for example, we have has, we have her, we have his, we have mine, we have her, we have your. Take, for example, the visitors are in your house. If you look at this sentence, you will see that the only word showing possession in this sentence is your. It's your, and that's why we underline your as the possessive adjective in this sentence. Let's take another example. My uncle lives in Lagos. My uncle lives in Lagos. If you look at this example, what is showing possession in this example? I believe you should be able to identify the particular word showing possession. And what's that? Okay, mine. So my uncle lives in Lagos. We would now take another example on that again. Her teacher is hardworking. Can you identify possessive adjective in this sentence? Okay. Her. That is the possessive adjective in this sentence. So we say her teacher is hardworking. Can you construct 3 or more sentences on a possessive adjective? And of course, you have to identify by underlining those adjectives in the sentences that you have constructed. We take the next type of adjective, which is interrogative adjective. Interrogative adjectives. And of course, interrogative adjectives ask questions on the nouns they describe. I'm sure you like this because for a student that is inquisitive, you use more of interrogative adjective. When you're asking questions, say what, whose, which. You know, those are the examples of interrogative adjectives that we use when we are asking questions in class, in the classroom. Now let's look at some examples. What pet do you want to get? Always remember, whenever you are using interrogative adjective in a sentence, you have to put the question mark at the end of each sentence. So we have, what pet do you want to get? What pet do you want to get? Now looking at this example, what do you think is the interrogative adjective in this sentence? I believe your answer is what. What, because that is the word there that we are using to ask question. Let's take another example. Whose child is this? Looking at this sentence, I'll say that whose is the word that we are using there to ask a question. Whose child is this? So we underline whose as our interrogative adjective. And I'm sure you should be able to construct your own sentences at home using interrogative adjectives. But before we leave this type of adjective, let's take one more example. Which student took the book? From this sentence now, I believe you have already underlined which. because which is the interrogative adjective in this sentence. Which student took the book? Which is a word that we are using to ask question. So which is the adjective in this sentence? So practice more at home, and as you are practicing, you are underlining the adjective, or if you have more than one adjectives in your sentences. So I believe that by now you should be able to explain adjective. You know, like, remember I told you that adjective describes or qualifies a noun or a pronoun in a sentence. And when praying to God, when praising God, remember to use beautiful adjectives to also describe God, to eulogize God whenever you are praying to God. And of course, practice more when you are talking, you are conversing with a person, using beautiful adjectives to describe people, places, and so on and so forth. And of course, I believe that you should be able to list types of adjectives that we have looked into today. We have considered adjectives of quality. We have discussed adjective of quantity. We have also discussed demonstrative adjective. We have looked into possessive adjectives, and I told you that possessive adjectives, we use them to show possession. And of course, we have also discussed interrogative adjectives. And I told you that interrogative adjectives are adjectives that we use to ask questions. We use them to ask questions on the noun they describe. And I believe that you should be able to mention examples on each type of adjective that we have discussed today. Now, take this down as your assignment. Ibadan is a large, busy city. 2, Becky's sister gave her a black heart. 3, her funny neighbor is hardworking. 4, I bought some big tubers of yam. And 5, that slim boy is a good dancer. So have a great day.
Good day, viewers at home. I welcome you to CRSM virtual class. My name is Olatubosun Ogutunde, and the subject that we are going to look at today is mathematics. And the topic is variation. And we started this topic last 2 weeks. And I gave you an assignment which I promised to provide a solution. And for the assignment I gave last 2 weeks, these are the solution. And for question number 1, formula connecting x and y is x equal to 5y over 3. For question number 1, I mean solution to the assignment I gave last 2 weeks. The formula connecting x and y is 5y over 3. And when x equal to 2 over 7, that is when x equal to 2 over 7, then y equal to 6 over 35. So when x equal to 2 over 7, y equal to 6 over 35. That is the solution to question number 1. And then for question number 2, the formula connecting wages and number of hours is W equal to 2H. W represents wages, while H represents the number of hours. Now, for Roman figure 1, when hours equal to 7, that is when H equal to 7 hours, then W, that is the wages received, is 175. I repeat, when hours, that is H equal to 7 hours, the wages received is 175 naira. And for Roman figure 2, when wages, that when W equal to 800 naira, the hours worked for, that is H, equal to 32 hours. That is, when the man received 800 naira as wages, he worked for 32 hours. So that is the solution to the assignment given last 2 weeks. And today, we are moving to the second type of variation. Second type of variation, which is inverse variation. And what is inverse variation? Inverse variation is when an increase in one quantity or variable causes decrease in the second quantity. That is, when one quantity is going up, the second one will come down. So this type of variation is what we refer to as inverse variation. Now, at the end of this teaching, what are we expecting from you? 1, you should be able to define inverse variation. That is number 1. Then number 2, you should be able to differentiate between direct and inverse variation. And the last one, you should be able to solve problems on inverse variation. So these are the 3 things that we are expecting from you after the end of this lesson. Now, let's move to the steps that involved in solving this particular type of variation. 1, we have, if you could remember, when we are treating direct variation, I gave these steps that you need to take. And this same step is what I'm going to apply in this particular variation. Number 1, we are going to write correct equation for this inverse variation. That's the first thing we're going to do. Write correct equation for the inverse variation. Now, in this case, let's assume that P varies inversely as Q. P varies inversely as Q. So if you want to write equation to represent this variation, so this is how you are going to do it. So we are going to have P varies inversely as what? If you want to write, what is the inverse of Q? That is Q raised to power minus 1. And if you want to change that to fraction, that will give us 1 over Q. So this represents inverse of Q. So this expression represents inverse variation. So it means when P is increasing, Q will do what? Q will decrease. So this is the equation that represents inverse variation. And from here, what is the second step? The second step is to change this sign of proportionality to equal to. We have discussed that when we were treating a direct variation. Now, the next thing we are going to do is to introduce a constant. And that constant is what? Is K. So I'm going to multiply the right-hand side by K. So I'm going to have K multiplied by 1 over Q. So from here, I'm going to have P equal to K over Q. So this is the final equation of inverse variation. So any question that you want to solve under this particular variation, so this is the equation that you are going to use. I come again, you are going to write equation, and the inverse is 1 over whatever that you are given. And then you introduce a constant. That is the next thing. Then when you introduce a constant, it means your right answer, you are going to multiply it with the constant that you have chosen. So the final one is going to be P equal to K over Q. So that is the final equation. Now let's look at the examples. Let's look at the example 1. So we have if P varies inversely as the square of x, and P equal to one whole number 1 over 4, when x equal to 4, find A, the formula connecting P and x, then B, P when x equal to 1 over 4. And the last one, which is C, find x when P equal to 5. So these are the questions that we are going to look at now. And what are the variables that we are having in that particular question? We have 2. We have P and x. So these are the 2 variables in that particular question that we are given. Now, what is the first thing to do? Generate an equation for P and x. And don't forget that we are not dealing with direct, we are dealing with inverse variation. So we have P now is what? Varies inversely as x. That is 1 over x. But don't forget that it is not x, it is square of x. So we have x squared. So P varies inversely as square of x. Then what is the next thing? Then we introduce a constant. So we have k multiplied by 1 over x squared. Then our P now equal to k over x squared. So this is the final equation. Then let's get our unknown. What is the unknown? That is the k. Then we are given 2 values. That's the first one, when P equal to one whole number 1 over 4, and when x equal to 4. So these are the 2 values that we are given. Then what are we going to do? Then we are going to substitute these values into this equation. So we have, what is our P? That is P equal to one whole number 1 over 4. So this is mixed fraction. So we have to change this one to improper fraction. Mixed fraction to improper fraction. So we have 4 multiplied by 1, that is 4, plus 1, that will give us this P now equal to 5 over 4. So let's substitute this value into this equation that we have derived. So we have 5 over 4 equal to k, unknown. Then what is our x? Our x equal to 4. So we have 4. Don't forget to put square, because square is part of x. Then we have 5 over 4 equal to k over what? Over 16. Then cross multiply. So we have 4 multiplied by k. That will give us 4k. Then we have 5 multiplied by 16. So we have 4k now equal to 5 times 16. That will give us 80. Then how can we get our k? To get our k, it means we are going to divide both sides by the coefficient of k. What's the coefficient of k? That is 4. So we divide this side by 4. Then you divide this side also by what? By 4. This and this will cancel each other. Then we have our k to be equal to 4 here 1, 4 in 80. That is 20. So we have our k to be equal to what? To be equal to 20. So the constant now, the value for that constant is 20. Now, if you look at the first part of that question, it said that find the formula connecting P and X together. The formula connecting P and X together. Then what's the formula connecting P? and x together. So you now go back to this. You go back to this, then you substitute for k. When you substitute for k, so we have p now equal to 20 over what? Over x squared. So this one is the formula connecting p and x. I repeat, the formula connecting p and x is when you substitute value of your constant. What's the value of that constant? That is 20. So p now equal to 20 over what? Over x squared. So that is the formula connecting p and x together. Then the next one is, so this one is A. Then we move to B. What is B? B says find P, that is P is unknown, then our X is equal to 1 over 4. So P is what we are looking for when X is given to be 1 over 4. Then we start our solution from the formula, that is P equal to 20 over what? Over x squared. What is our P? Is what you are looking for. So P now equal to 20. What is our x? We are given 1 over 4. So we have 1 over 4, everything raised to power what? Raised to power 2. And from this place, don't forget that numerator and denominator both are affected by this square. So we have P now equal to 20. 1 raised to power 2, that still remains as what? 1. Then 4 raised to power 2, that will give us 16. Then from there we continue. So we have P equal to, that is 20 divided by 1 over 16. So this is numerator on its own. Then everything here is regarded as denominator. So this division sign is the same thing as this sign, over. So we have P now equal to 20. Then don't forget that the denominator of 20 here is what? Is over 1. So when you have division sign in between two fractions, what will happen? So you have to change to multiplication sign, and the second fraction will now turn upside down. The second fraction will now turn what? Upside down. The numerator now become denominator. So we have 20 over 1 multiplied by 16 over 1. So P now equal to 20 multiplied by 16. That will give us 320. So it means when x equal to 1 over 4, P equal to 320. So when x equal to 1 over 4, P equal to 320. Now let's look at the last one, which is a C. We are looking for x. X is unknown, then P equal to what? Equal to 5. Then how can we get x? So we now go back to this formula connecting both of them. So we have P equal to 20 over what? Over x squared. Then what is our P? Our P is 5. Then we have 20 over what? Over x squared. Then what are we going to do? Then this one, the denominator is what? Is 1. We cross multiply. So we have 5 times x squared. That is 5x squared equal to 20 multiplied by 1. That is 20. Then from there, we are looking for x. And if you look at x squared, the coefficient there is 5. Then we also have a 20 in the right-hand side. So the first step to take is to eliminate the coefficient of x, which is what? Which is 5. And to do that, we are going to divide both sides by 5. So we have 5x squared equal to 20 divided by 5. So we have this cancel each other. Then we have x squared now equal to what? Equal to 4. And what we are looking for is not x squared. It is x that you are looking for. And to get our x, What are you going to do now is, we are going to take square root of both sides. Take square root of what? Of both sides. So if you take square root of x squared, then we have square root of 4. So the square root here, we eliminate square. So we are going to have x now equal to what? Equal to what is square root of 4? The square root of 4 is what? Is 2. So from this place, we can see that when p equal to 5, our x equal to 2. When p equal to 5, x equal to 2. That is the solution to example 1. Then let's move further to example 2. Now, if x varies inversely as the cube root of y, and x equal to 1 when y equal to 8, find y when x equal to 3. And from that question, we have two variables. We have x and what? And y. So these are the two variables that we have in that question. And let's look at what we are given. X varies inversely as cube root of what? Of y. So this is the expression of the question that we are given. Then what are we going to do next? So we are going to change this one to equal to. So we are going to have x equal to k over cube root of what? Of y. So this is the equation that we are going to use to get all that we are asked to find. Now, from here we are given x to be equal to 1. Then we are given y to be equal to 8. So these two values is what we are going to use to get our unknown, which is a constant. So we have x, which is 1, equal to k over what? Cube root of 8. Now, what is cube root? Now, cube root means same number that when you multiply it 3 times, it will give you what you have in the root. I repeat, cube root means same number that when you multiply it 3 times, it will give you number in the root. Which number can we multiply 3 times? That will give us 8. Is that what? 2, correct. So we have 1 now equal to k over 2. So when you multiply 2 3 times, 2 multiplied by 2, that is 4. 4 multiplied by 2, that is what? That is 8. So cube root of 8 is equal to 2. So now, how can we get our k? So our k now equal to, you cross multiply, 2 multiplied by 1. Then k now equal to 2. So the next thing now is to find the formula connecting x and y. Formula connecting x and y. So we have x now. What is our k? Our k is equal to 2. So substitute 2 here. So we have 2 over what? Cube root of y. So this is the formula connecting x and y together. So any other problem, this is the equation that we are going to use to get the answer to the problem. Now, we are looking for y when x equal to 3. We are looking for y. Y is unknown. X equal to what? X equal to 3. Now, from this formula, we substitute. So we have x, which is 3, equal to 2 over what? Cube root of y. 3 equal to 2 over what? Cube root of y. The denominator here is what? Is 1. Then we cross multiply. So we have 3 multiplied by cube root of y equal to what? Equal to 2. And from this place, don't forget that 3 is coefficient of cube root of y. 3 is what? Coefficient of cube root of y. And to eliminate it, it means again to divide both sides by 3. So divide this, everything here by 3. Then you divide this also by what? By 3. So this and this will cut each other. So I'm going to have cube root of y equal to 2 over 3. Cube root of y equal to 2 over 3. Then now, how can we eliminate cube root of y? How can we eliminate cube root of y? Then I will take you back to law of indices. Law of indices. That is when you have something like, let's say we have a raised to power 1 over 3 is the same thing as what? Cube root of a. So a raised to power 1 over 3 is the same thing as what? Cube root of a. So we are going to apply this here. So we can now say that we can change this one to y raised to 1 over 3 equal to 2 over 3. And from this place, how can we eliminate 1 over 3? That is, how can we change this power to 1? To do that, we are going to apply multiplicative inverse. What do I mean? Two numbers, when you multiply them together, it will give you 1. Now, what is the multiplicative inverse of 1 over 3? So the answer is what? 3 over 1. So it makes reciprocal of 1 over 3. So we are going to multiply both powers, I mean in the left-hand side and right-hand side. We are going to multiply it by what? By 3 over 1. So I get to have y now, which is y raised to power 1 over 3, multiplied by multiplicative inverse, 3 over 1, that is 2 over 3, raised to power what? Raised to power 3. So this and this will cut out, and this will now become y. So we now have 2 raised to power 3, that will give us 8. And 3 raised to power 3, that will give us what? 27. So it makes when x equal to 3, y equal to what? 8 over what? Over 7. I repeat, when x equal to 3, y equal to what? 8 over what? Over 7. So that is the solution to question number 2. And the last one for today, that is example 3. So this one says, if m varies inversely as n, and m equal to 3 over 7 when n equal to 21, what is the value of m when n equal to 2 over what? Over 5. So we have two variables, that is m and n. Now write the equation for the two of them. So we have m varies inversely, that is 1 over what? Over n. Then we have m now equal to k over n. And we are given values, that is m equal to 3 over 7, and then n equal to what? Equal to 21. Now let's substitute these two values to get the constant k. Then we have 3 over what? Over 7 equal to k over 21. And from here, we are going to cross multiply. When we cross multiply, we are going to have 7k equal to 3 multiplied by 21. And 7k now, 3 times 21, that will give us 63. So we have 7k equal to 63. And what is the next thing? To get our k, so we have to divide both sides by 7. So you divide this by 7, you divide this also by what? By 7. So this and this we cut out. Then we have our k now equal to what? Equal to 9. So it makes the constant that we introduce, its value its value is what? Is 9. Now from here, what's the next thing to do? We are going to write equation connecting the two together. So we have m now equal to 9 over what? Over 9 over n. So this is the formula connecting m and n together. So this formula is what we are going to use to solve for the last one. So we have m is unknown. Then we have n to be equal to 2 over 5. Then we substitute. So we have m now equal to 9 divided by 2 over 5. So that will now take us to m equal to 9 divided by 2 over 5. So we have m to be equal to 9. And don't forget what I told you before, that when you have two fractions, in between them, we have division. Then the other fraction will turn upside down. That is, numerator becomes denominator. So we have multiplied by 5 over 2. Then we have 9 multiplied by 5. That will give us 45 divided by 2. So m now is, you take this to mixed fraction. That is 22 whole number, 1 over 2. That is, we can see 2 in 45. That is, 2 in 45 will give us 22. And the remainder is 1 over 2. So now, that is when n equal to 2 over 5, our m equal to 22 whole number, 1 over 2. Now, let me summarize all that you have done. Now, I gave you the definition of inverse to be, that is, inverse variation is one in which an increase in one quantity results into a decrease in the other, and a decrease in one quantity results into an increase in the other. Now, let me give a good real example. A good real example of inverse variation is law of demand. Law of demand. We said that the higher the price, the lower the quantity demanded. And the lower the price, the higher the quantity demanded. It means when price goes up, the quantity demanded will come down. And I pray Almighty God will help us in Jesus' name. And before I go, I will give you this assignment. And when I come next time, I will provide a solution. The assignment is displayed on the screen. Then you copy it, not copy it alone. Practice so that you can be perfect. And I pray Almighty God will make you perfect in the mighty name of Jesus. Thank you, and God bless you.